The last thing we have to learn in section 8.1 is equations of quadratic form. So we are on page 7 of our packet, and equations of quadratic form is going to be a little bit more difficult than solving just like equations that are just straight up in quadratic form. Quadratic form equations look like this. We usually say like ax squared plus bx plus c is either equal to y, or we usually change it equal to 0 so we can solve it for where it crosses the x-axis. But this is usually like what we're dealing with. And to solve these types of equations, we can solve using factoring, we can solve using the square root method, and that is really kind of all we know how to do at this point. We know how to also solve using or solve problems that have complex solutions, but those usually require us to use the square root method. So those are the two methods that we know how to work with at this point. But now we're going to be solving equations that actually are not quadratic equations, but they are equations of quadratic form. So it's super important to understand what that means. So an equation that is of quadratic form might not be an actual quadratic. A quadratic definitely has x squared. But another definition of a quadratic is also that the middle term, this term right here, is going to be something. And then if you square that middle term, it actually is the first term. So if we take x and we square it, it's x squared. We're already used to seeing that in quadratics. But what we're going to see is interesting problems like this equation here that is clearly not a quadratic equation because it's not x squared. It's x to the 4th power plus 5x squared plus 4 equals 0. But actually, it is an equation of quadratic form because technically, if we square x squared, it equals x to the 4th power. So it actually can still be solved using either factoring or the square root method. So it's kind of confusing at the start, but here's what I need you to really think about and watch here. So if we've got some equations in quadratic form, or writing them in quadratic form when they're not, here's what you're looking for. First, look for the middle term and look specifically for the x. This is x squared. Take that middle term, so basically take middle term and square it. If you take the middle term and square it, and it turns into the first term, and I'm not talking about coefficients, I'm just talking about the variables. If you take the variables like x squared and you square it, x squared squared, and it equals x to the 4th power, which is what the first term is, then you're checking it off the box. It is an equation that is of quadratic form. So this first equation here can be rewritten in quadratic form by basically taking your middle term, which is 5x squared, and squaring it, and you're going to get your x to the 4th power. So it's really like taking, let me rewrite it, this is just like the minus 5x squared plus 6 equals 0. I'm basically going to take this x squared and square it, and it turns into x to the 4th power. So we actually have a squared, technically this is like a regular x, and then a constant equals 0. For this next one, it's going to feel a little bit different. We have the square root of x as the middle term. If we take the square root of x and we square it, it equals x. And that is what the first term is. So this one also checks out. So if we take that middle term, like the negative 3 square root of x, I'm just going to write the rest of this equation. We take that square root of x and we square it, it really does equal x. The square root of x squared is really equal to x, so it works. The next one, x to the 1/3. If we take that and square it, it equals x to the 2/3 because we would multiply the exponents here. And that also checks out because x to the 2/3 is here as well. So if we take that minus 13, x to the 1/3, and then plus 6 equals 0, and we take the x to the 1/3, and I know it has a coefficient this time, I'm just going to put the 5 out front, but we take the x to the 1/3, and we square it, it's x to the 2/3, so it actually is an equation of quadratic form. And then the same thing with this one. We can see x squared minus 6x is being squared, and the actual coefficient, or the actual x here, is the same, and then it's just being squared here. There's actually really nothing to write out. Really, the equation is already set up to be of quadratic form the way that it is, because we've got -2 times x squared minus 6x, that's like your x term, minus 35 equals 0. And if we take that x term, x squared minus 6x, and we square it, we have like the original already. So there's really nothing to do for that one. So that's kind of, and it's confusing, but that's kind of how this rolls. But here's how to solve them. So we do not know how to solve equations like letter A, x to the 4th power minus 10x squared plus 21 equals 0, algebraically, unless we think of it as a quadratic and then we factor it or use the square root method to solve it out that way. So what we need to do first is just make sure that if I take the middle term, which is x squared, and I square it, it has to equal the first term's x. So x squared squared is x to the 4th, so this one will work out. And here's what we do. We kind of like play this pretend game, like let's pretend this equals that, and we use substitution. And then this is difficult to really understand. It's kind of abstract. So you can use any variable. Sometimes I've seen, like in college, they use the letter U. Sometimes they use the letter A. Up here in our notes, it looks like they're using U here, so let's use U. Okay, so here's what we're going to do. You always let U equal the middle variable. Ignore the coefficient. So in this case, U equals x squared. And then what we will do is we will square the whole equation. So square U equals x squared. So here's what I mean by that. U squared, square the U, and square the x squared, which is really x to the 4th. What we would then do is use these two pieces of information and we basically substitute them in. So we use substitution next. So x to the 4th power right here is the same thing as U squared minus 10 x squared is the same thing as U plus 21 equals 0. What we did is we substituted in U and U squared in for x squared and x to the 4th to make it look more like a quadratic. Once we use substitution, then we solve the quadratic by factoring or square root method. Oops. Okay, so this one can be factored. What multiplies to be 21 and adds to be -10, that would be -7 and -3. So we would factor this into U minus 7 in any order times U minus 3 equals 0. We still follow the same process as before. We're going to set both of these equal to 0. So U minus 7 equals 0, U minus 3 equals 0. Solve it out. we get 7 as an answer, and we get 3 as an answer. Only thing is we're not actually done. So even though we have 2 answers here, the original equation has nothing to do with u. So what we have to do next, now that we have an answer for u, is we have to substitute back in so you have the x variable back. So we know that u equals 7. Right here, we have u is actually equal to x squared. So we're going to replace in x squared in for u. And then now it says x squared equals 7, and same thing here. We're going to replace an x squared in for u, and now we have x squared equals 3. Then what we do is we solve those new equations, which sometimes requires the square root method, sometimes requires some extra factoring, sometimes requires whatever. We just have to now look at these equations and solve both of these. So to solve x squared equals 7, we would square root both sides. Don't forget that when you square root, there's going to be a positive and negative answer. So this is going to cross at positive and negative 7. Positive and negative square root of 7, sorry about that, square root of 7. And then here, it's going to cross at positive and negative square root of 3. This equation has 4 answers. It's not a quadratic, it's actually a quartic. This quartic equation will cross the x-axis at positive square root of 7, negative square root of 7, positive square root of 3, and negative square root of 3. If you were to type this in your calculator, so if I just go over to Desmos really quick, and I type this example in here, y equals x to the 4th, and then minus 10x squared plus 21, I can see that it crosses the x-axis at 4 spots. 1, 2, 3, 4. And if I figure out what the decimal versions of these numbers are, the square root of 7 is like 2.64575. So we can see it happens at negative that and positive that. And the square root of 3 is the 1.73 number. So positive that and negative that. So that's where that comes from. All right, so if we then try another one, they're all going to look different and feel different and be different. So the next one we've got, you can kind of trust that the equations are in quadratic form, but to verify, you take the middle term, which is the square root of x, and square it. The square root of x squared is x. Yes, that is a quadratic, an equation of quadratic form then, because it checks out. So now what we would do is we let u equal the middle variable. So the middle variable is the square root of x. And then we take u and we square it, and we take whatever this is and we square that to get, in this case, u squared equals x. Here's our 2 things we're going to be using throughout this process to substitute in and substitute back out. We're going to replace x right here with what x equals. X equals u squared. And then minus 11 as it is. We are going to replace the square root of x with what the square root of x equals, which is u, and then rewriting the rest of the equation. And at this point, you should be seeing a quadratic equation. U squared minus 11u plus 24. And this can be factored. So what multiplies to be 24 and adds to be negative 11 would be negative 8 and negative 3. So u minus 3 times u minus 8 equals 0. Solve both of these. We get u equals 3 and u equals 8, but we're not done. What we would have to do then is substitute back in. So you look back at this information and you figure out, all right, where's the u at? U is right here. U equals the square root of x. So we replace in the square root of x for u here and here. And then we solve these equations for x, because our whole goal is to figure out what actually x is. So this one's different. This one is the square root of x equals 3, and we have to undo the square root of x. So to undo that, we square both sides. So when I square the square root, those cancel out. I'm left with x equals 9. It's just positive 9. It's only when you square root something that you get plus and minus. If I square something, it's just one answer. It's 9. And then squaring this side and this side, x equals 64. So we get two answers, x equals 9 and x equals 64, where this would cross the x-axis. And honestly, it is really helpful for you to take your Desmos calculator and put this into it so you can actually see why you're doing what you're doing and verify it and allow it all to click. So what I want you to do is go ahead and try the 2 checkpoint questions.